Hi. Does that look really weird?
Yeah, kind of.
That's my eye.
All right, welcome, friends. Today we're going to be analyzing quadratic functions. Yay, math?
Now that we got that out of the way. All right, let's jump right in. Ready? Okay. Okay.
So we're taught.
It's like, yeah, you gotta just get it done. All right, cool. So again, we'll start with the basis. What's this shape? Parabola. All right, so let's graph it. Okay, it could be a small one. We're going somewhere with this. Okay. Next, what do you think happens? What do you think happens if I were to write y equals x squared plus 2? What do you think happens to this parabola?
It moves.
It moves. It does move. Where do you think it moves? Up, down, left, or
It
right?
goes up to.
Okay, this goes up 2. Yes. If it says plus 2 here, it starts 2 units up, and then it looks exactly the same. So let's graph that one. I want 2. And there. Questions about that? Okay, more. What about y equals negative x squared? We've talked about this. It's upside down, right? Y equals negative x squared is upside down. So what would be y equals negative x squared plus 2? What would that be?
Down.
Up to going upside down. Right on. So that would be here. Questions on that so far? Okay. So, something just to put in the back of your minds for a second. This y equals x squared plus 2. If we started at up 2, what is our vertex?
2.
Vertex.
2, 0.
0, 2. Good. All right, keep that in the back of your mind. Next, y equals. Okay. Now we snuck in a negative 3 inside the squared. Remember, it's always going to be squared. If there was no squared here, what would this graph be? Just a line. Yeah.
The Y's aren't in the camera.
What? Which one's
Should I
not?
turn the camera? Because
Oh, what's not?
the left side.
Okay, you can pause it. We'll be back. And we're back. I wonder how that looks. It's going to look like this. All right, we'll be back, and we're back. All right, so we snuck in a minus 3 here. So think about it. If this is up 2, and if it said minus 2, it would be starting it down 2, of course. Is this up or down, or is this left or right?
I think it's left or right. Left or right.
It's left or right. This is left or right.
How do you know?
Okay, the one that's, exactly. I think this is an intense lesson. The one that's on the outside is the up or down one. And the one that's on the inside, next to x, right? X is left or right, correct? This is the x-axis. If this is the x-axis and it works left to right, then naturally the number next to x would be the left or right movement. Okay?
So it's always going to have a square?
No. This number here is the amount that we move left or right, and I'm going to explain which one we move in a second.
Oh.
Again, the number on the outside of the squared, out here in space, is the up or down one, because it applies to y. For example, if we were to subtract 2 on both sides, it would be next to y. All right? It's hanging out with y. And if a number is hanging out with y, then it's an up or down shift. It's called a shift, by the way. And if a number is hanging out with x, it's a left or right shift. Questions on that concept?
No.
It's okay if you do. Okay, so now, who knows? It's either left or right 3. What do you think? Yeah.
Right.
It's right 3.
Yeah.
It's right 3. All right. The way I remember this is that the one on the inside here, it's like the amount of space that would make this 0. Like if x was 3, positive 3, it's to the right 3. Another way people look at it is like it goes by opposite. So the opposite number in here. The opposite number in here. So if it's negative 3, we go to the right. Observe. So we look at minus 3, we're thinking, okay, so I'm not going negative, I'm going positive. 1, 2, 3, and starting here. All right? Questions on that?
If it's negative, you move to the right.
If it's negative, you move to the right. Let's do another one. Y equals x plus 2 squared. Left or right?
Right.
Left.
Left. Right. As in, yeah. One person? I love puns. With that voice too. That voice sounds like velvet. Black velvet. Before your time. It's all good. You know what song stuck in my head is? Na 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 na. I wanna make
I hate
up.
that song.
Me too.
It's
Please.
so annoying.
Banish it from my brain. And so there it is. So now we're ready to intensify. Here we go. Intensify by doing the following. This one will have a vertical shift and a horizontal shift. Y equals. Give me numbers.
3.
Plus or minus 3?
Minus 3.
Minus 3 squared. Give me numbers.
Plus.
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 4.
4. Fine, let's do 4.
Oh.
I get it.
Yes.
Okay, can I do it?
Sure. Okay, well let's do it. Does everyone have it written down?
This part.
Okay.
Okay,
I'm giving the camera the full shot of the shirt.
you
Because I
go.
believe in it. Yeah. A question first.
Yeah. What, like I get it, but like which one do we take first, from left to right?
Doesn't matter.
Does it matter?
Doesn't matter. No. You go this way, that way. It doesn't matter. It's like if I was walking to you, I would still get to you if I went this way and then over, or if I went this way and then over. It's like I'll still get to you. All right. So it doesn't matter which way. Have you ever like driven on a street that's a grid, and like it doesn't matter if you go like right first and then up,
Yeah.
or like up and then right. Yeah. Okay, so you have where we're starting.
Okay, so
I like to start from here though because it's easy to me. Where are we starting?
you go up 4,
Up 4,
and then you go to the right 3.
right 3. That's it. Up 4,
Oh.
right 3. And what's this point?
It's
Yes?
imaginary.
No? Oh, okay. I know what you're thinking, but what's this point first?
Oh, the vertex.
The vertex, and what is that vertex? What, comma, what?
3. 3, 4.
3, 4. Questions? I heard other people saying it. That's good. 3, 4. And the parabola opens up or down.
Uh-oh.
Yeah, there's no negative here. It opens up. And just to follow, could you expand on what you were saying before about imaginary?
They're imaginary roots.
Imaginary roots, yeah. The solutions are imaginary because it doesn't cross here. So that's a good thing to note. All right,
Can you read that
so
one more time?
yes, solutions are imaginary.
Should we write?
Solutions, you should know it. If you don't know it, write it down. It's a good idea. The solutions are imaginary because we talked about solutions are when they hit the x-axis, right? Like numbers, when the parabola hits the x-axis here, solutions are here and here. These are real numbers. But since this doesn't hit the parabola, or because it doesn't hit the x-axis, there's no real solution for this. We talked about that in another class. I want to stick to this. Okay, so check it out. Do you think you can look at this and see hiding inside the vertex?
Yeah.
You look at any parabola now in this form and be like, oh, I know the vertex. The vertex is positive 3 and 4. That's why this is called vertex form. Right? This is called vertex form. All right, and there's one other piece that we're going to talk about, and that's I want to cut it at that today. Keep it clean. one other piece. And this is what it is. Can anyone guess? Okay, we access this part of the parabola. We access this part of the parabola. Is there other places that we can introduce new numbers and new specifics, new details? Anywhere else? That we could add a number? Yeah, what do you think?
Could it be like the minimum or maximum?
Min or max is the vertex.
Oh, I mean like up. Never mind.
What about here?
Oh, yeah.
Is this always
Yeah.
1?
No.
No.
No. Remember the term for this? It's a letter. What's the term out here?
Constant.
A. Good. It's A. It's A. So now we're going to talk about A. Okay. When A is a fraction, when A is like a fraction, we're talking 1/2, 1/4, 1/16, or these types of things. The more extreme the fraction, meaning like the smaller the fraction, what do you think happens to the parabola? Do you think it gets wider, or do you think it gets narrower?
Narrower.
You think it gets
It's wider.
you think it gets narrower, but actually gets wider.
Oh, yeah.
Because
True.
parabola becomes wider. I wrote this like this on this. And if A is a whole number big, A is 2 or 4 or 8 or 16 or these types of things, 7, 9, whatever. The bigger the number, what happens to the parabola now? Narrow. Yeah.
So the parabola becomes wider when the fraction.
When it's a fraction, yeah. How fun, huh?
So as the fractions like decrease.
Right. Narrow, wide. Now we're going to talk about graphing one. Let's graph one. Let's graph an extension of this. Let's make y equals -1/2 a, oh not a. I want to keep the same vertex, so x minus 3 squared plus 4. So let's graph. The task is graph this parabola. Graph this parabola. As an aside, as you're writing it down, as an aside, remember how we graphed before? How do we graph parabolas before? How do we get the vertex?
Negative B over 2.
Negative b over 2a, and then plug that number back in to get y, and then you plug in points. Recall that?
Yeah.
Negative b over 2a, and you plug in y. Now we already know the vertex, so we don't need to do that. Some would argue that this is an easier form of graphing. So we established that the vertex here is 3, 4. Here it comes. And we go 1, 2, 3, 1, 2, 3, 4. It's there. Okay, now let's do a t-chart. And what would be a good point to plug in now? So we already have 3, 4 in here.
0.
Okay, so let's think about plugging in 0 for a second. I'm going to talk this through. Your Algebra 2, you can handle it. If we plugged in 0, no problem. We would get 0 minus 3, which is
Negative 3.
-3 squared is 9 times a half. We're in fraction then, right? So let's see if we can do it elegantly without getting a fraction. What do you say?
3.
3.
So that 3 minus 3 is 0.
Where do you have 3? 3, 4.
Yeah, I know
Good
that.
thinking. Try another one. Something in the neighborhood of this.
1 and 2.
1. Let's try 1. Let's try 1. Watch what happens. 1. Okay. Volunteer. We'll walk through it together, please.
Okay, so 1 minus 3 is
Negative 2 squared is 4 times negative a half is
Negative
2 plus 4 is
2.
2, like I said.
I like Michael's.
Let's do it again. 1 minus 3 is -2. Squared comes first. -2 squared is 4 times negative half. Negative 2 plus 4 is 2. 1, 2. Now check it out. 1, 2. So maybe you can see a slight wideness compared to just a normal x squared. You can see it. Normally it goes down 1 over 1. Now it goes down 2. All right, remember by the laws of symmetry. Laws of symmetry. Here, to get to this point, how far? We went left 2, right? And we went down how far?
1.
2 also. Let's put the point in. Look here, right here, perfect, perfect. To get from the vertex to this point, we went
Down 2.
down 2, we went left 2 for x, and we went down 2 for y. So if we went 2 and 2,
2, 2.
so now let's go to this way and down 2. So 5, 2.
How do you get 5?
Can you explain in your own words how we got 5?
If you look, when you do the
Loud, loud, nice and loud.
when you do the symmetry line, you went 2 to the left to get your first line.
Right, so we went
according
from
to
3.
symmetry, you have to go 2 to the right and 3 plus 2 is 5.
So we went from 3 to 1, right? So if we go from 3 to 1, that's 2 this way. So going 2 this way would be to
3
1.
and then 2.
So 2 that way would get us to 5.
Alright.
If I'm standing at 3 and I went 2 this way, I would get to 1.
Okay.
But now I want to go 2 this way. Where would I end up? 5. Okay. Good. And last problem. Last one. Oh, I didn't finish the graph. So yeah, 5, 2. There. When I was a kid, no joke, when I wanted to spend the night with my cousins or something, we'd be together on Saturday night, all having dinner, and I was a kid, like, let's spend the night, it's so fun to spend the night, you hang out, stay up. And then the parents would hear us saying, spend the night, and then they'd be like, no spending the night, because that made more work for them. And so we came up with a code for spending the night. I can't get over that story, man. I love that story.
Wait, are we still recording?
Yeah.
Wait, what was the code?
What's the code for spending the night? What's the code for spending the night?
I never heard this story.
5, 2.
Why?
I don't know.
Wait, so how would you get us then?
We would like plan and plot.
Why didn't you just go to sleep and then get ready to go out?
And then my parents, do you remember what they said when I was like,
We'll
"Can
tell you when we get home."
We'll tell you. We'll tell you in the car. We'll tell you in the car.
Are you gonna do that to your kids?
That's so sneaky.
I know. Definitely not gonna do that to my kids. I'm gonna be like so patient with them. Serious. I'll be like, you can't do that, bro.
That's a lot better.
What is the equation of the
equation?
Come on, man.
How much time's passed? Does it tell us?
1851.
18. Okay, we're on
No, so
point.
it's 19.
Okay, 19. The equation of the parabola with vertex -1, 4 and passes through the point 2, 1. Yes, sir.
Are we doing this together?
Yeah, we're doing it together.
Oh.
This is our finishing act, our curtain call.
Okay.
All right. Now, we know vertex form, how it works. We know vertex form. Y equals. Now, looking at this, do we know what A would be? No.
No.
A could be 1, it could be 2, it could be a half. So let's just write A. We don't know vertex, we don't know what A is. What do we know? Yes? Vertex. We know the vertex? How will we incorporate the vertex into vertex form? What do you say? Yeah, what do you say?
Me?
Yeah.
X
X what?
-1 +1 Squared.
X minus 1 plus 1
No,
squared?
x plus 1 squared. That's right.
No, he's right.
Plus 4.
Plus 4.
Thank you, sir.
Questions? How'd you get it? That's the question. Yeah.
You said
What's the vertex here? How far left do we go?
1. No. 4.
Left, we go left 1. So we go -1,
Up 4.
and then we go up 4. Right?
the vertex is in the problem.
The vertex is hiding in the problem. The vertex is hiding the opposite of this number, and it's this number.
So what does 2, 1 have anything to do with this?
We're going to get into that. We're going to get into that. Remember, when we looked at this at the beginning, and the previous problem we did, you said, oh, left 1. So you go this way. You say, oh, okay, up 4. So if we go left 1 and up 4, that's this point. Let's graph the point. Let's start it off. Okay. -1, a 1, 2, 3, 4. All right, and now it passes through the point 2, 1. Let's graph 2, 1. Still with me, guys?
Oh,
Is it all right? Can you believe this is only half of it? This is only half, man. We're going to cut it now and we'll pick it up next time. All right, now we need the equation. Would you agree that we're almost done with the equation? We just need a.
Symmetry.
But, okay, we can graph it, but what's the equation? What's the equation? I'm going to tell you how to do it. Do you recall way back when? This is the expression for way back when you put your hand behind your head next to your ear. So next time I'll be like, do you? You're like, yes, and someone will be like, no, but we're communicating. Okay. So do you remember when we said if a point is on a graph, what does that mean for the relationship of the point and the graph? Yes?
You can plug it in.
You can plug it in. That's right. If a point is on a graph, it works inside the equation. Questions about that? It works inside the equation. Okay. For example, just quick aside, some points that work in this equation are 0, 0, 1, 1, 2, 4. These points work in the equation, so these points are on this parabola. But 1, 5 is not. Because 1, 5 does not fit inside the equation, 1, 5 is not on this particular parabola. Cool? So let's plug this point in to let it, it's like, oh, let me explain better, I'm losing my words. If we plug this point in here, this parabola will accommodate this point, thus keeping the point on the graph. So here we go. Instead of y, what are we going to write? 1 equals a
2 plus 1.
x
2.
plus, oh, 2, good job, 2 plus 1
Squared plus 4.
squared plus 4. And now can we solve for a?
Yeah.
Yeah, it's one variable left. So now we're going to solve for a. Order of operations, don't forget.
13.
A times what's 2 plus 1 squared? 9. Plus 4. What do we do to both sides?
Subtract.
Subtract 4. So we get 9a equals -3. A equals -1/3.
Okay.
A equals, bless you, bless you. A equals -1/3. Thus, the equation of the parabola.
Wait,
Yes, please, question.
how did you get that?
So we plugged in 2, right?
No, I mean after you subtracted 4.
Subtract 4, so a times 9 is 9a, right? 9a equals -3 because 1 minus 4 is -3. Is that legible?
Yeah.
It's kind of at an angle. All right, so now we solve a is -1/3, so we're done.
You did that.
Yeah, divide both sides by 9. Divide both sides by 9. So what's the equation? Y equals what?
-1/3.
Bravo. Negative 1/3. It's a pretty good day when you go from Southern to Italiano. Okay.
You know it'll be Chinese.
X plus 1 squared plus 4. Yes?
Wait, I'm confused on how you,
No, we
like,
didn't.
I
This is
got
for
negative
visual.
3 over 9.
Simplify that, please. Common factor of
3.
3. Yeah. Quick survey. Who prefers vertex form versus the expanded form? Vertex form, hands? About more than half. The form we did before, negative b over 2a,
Actually,
No, I
Yeah.
like that one.
I like that one.
Well,
like a third. Yeah, 2/3 to a third. Interesting.
I like them both.
Are we
We
what?
have to do both on the test.
Yes.
They're gonna like tell us. which way.
Yeah. We have one. Exactly. So next lesson we'll say take a form that we've previously done and put it into vertex form. That'll be the next thing. But this I want you to look at and say, oh, vertex negative 1, 4. That's the goal for today. Any questions about that? The vertex is at negative 1, 4. It's okay if you have it. Wow, good. Okay, fellas, ladies. Yes, no question. Yes, please.
So, could it, for the vertex form, could the vertex ever be 0?
Yeah, that would be nothing in there.
It would just be x
X squared.
squared?
Yeah, like the beginning. X squared plus 2. Right, so I was bringing it back to that thought. X squared plus 2, the vertex was 0, 2. Excellent. Lovely. Well, you guys are you're just relaxed or you're tired. Which one is it?
It's Friday.
It's Friday. Okay, we can crack. So give me one more yay math for the road.
Yeah, ma.
Yay, ma!
I'm hitchhiking. That's what they do, right? I'm going over there.